Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at how to draw the logarithmic graph from the exponential graph. Now remember that the exponential function and the logarithmic function are inverses of each other, so we can actually graph the log function by reflecting the exponential function. So we can do this by reflecting the graph over the line y equals x, because remember that is where we reflect to draw the inverse. So recall that the exponential function is y equals b to the power of x. So to find the inverse, we swap our x and y, and we get x equals b to the y. Now remember, this is exponential form. Then we can change this to log form, and this will be y equals log base b x. Okay, so I also want you to recall the exponential graph. So the exponential graph looks like this. It starts in the bottom and it sweeps up. Or it can start from the top and swoop down. So either way, for both of these graphs, they're going to have a horizontal asymptote. So when we want to draw the inverse, so in this arrow I'm going to write the word inverse. Okay, which is x equals b to the y. I would reflect the graphs over the line y equals x. So I'm actually going to draw it in here. Actually, you know what? Let's draw it in on this top part so you can see what that looks like. So if I draw the reflection of this blue graph, y equals b to the x, when b, the base, is greater than 1, I'm going to get a graph that starts down here and then swoops to the right like this. So if this point here, was 0, 1, this point down here will be 1, 0. And then for the second graph, where the base is between 0 and 1, we're going to get a graph that looks like this. And this point here will be 1, 0, because the original point here was 0, 1, and all the points get swapped. So also, instead of having the horizontal asymptote, I'm now going to have a vertical asymptote. So, some features. Remember that the domain was all real numbers, and the range is greater than 0. And the equation of the asymptote of this base function is y equals 0 for the horizontal asymptote. So, for the log graph, we have the domain. Now x greater than 0, because it swapped. So the range was y is greater than 0. Now it's the domain where x is greater than 0. And then the range is y is equal to all the real numbers. And then the asymptote is now a vertical asymptote. So we have the equation x equals 0. So just to point out, all of the exponential functions will have horizontal asymptotes, y equals to some number, whereas all the log graphs will have a vertical asymptote where x equals to some number. So let's take a look at an example. So I want you to find the inverse of this equation here, and then I want you to graph both functions onto the grid to the right. So as a little review, let's find the inverse. We're going to swap our y and our x. And we need to move the 2 over to the left side because then we can get our 3 parts, our base, our exponent, and then the number or the value on the left. So writing this in log form, we get y minus 1 equals log base 3 and then x minus 2. And then now we can move the 1 to the right side. All right, so to graph this, I'm actually going to create 2 tables. The first table will actually be based on our original function, y equals 3 to the x minus 1 plus 2. So remember that we want to start with a number, which makes our exponent equal to 0. So here we have x minus 1, so we're going to start with 1. And then I'll pick 2, or actually we'll pick one number that's smaller than 1, so it's 0, and then we'll pick 2 numbers bigger than 1. So when we plug in 1, we do get 0, so 3 to the 0 is 1, and then 1 plus 2 is 3. And then we plug in 0, we're going to get negative 1, so 3 to the negative 1 is 1/3, and then 1/3 plus 2 is 2 and 1/3. And then we continue plugging in the other numbers, and we will get 5 and then 11. So these will be the points for the original exponential function. So let's graph this. So 0, 2 and 1/3. Okay. So connecting my points. Oh, try not to draw the graph right where the asymptote would be, just because it is supposed to not be touching the asymptote. Okay, so now to draw the inverse graph, which is this log one, we could try to plug in numbers here, which it's difficult to do, or you can actually plug in numbers here where we have the swap of the x and y. Or because we already have the table of the original values from the exponential function, we now actually just need to swap them, and we will get the new values for the inverse. And so let's plot these points as well. And then let's graph, and again, try not to draw and cross the asymptote. So part B here says to identify the following characteristics of the inverse. So the domain, we can see that it's approaching this value right here. So the domain is actually x is greater than 2. And we can see that from the graph, the asymptote is x equals to 2. Now you can actually get the asymptote from this value right here. So recall that the number that when we're logging actually has to be a positive number. Actually, I'm not sure if we've said that before, but when we log a number, the number that we log has to be positive. So this is where the asymptote is, x equals 2. Now the range is going to be all real numbers because it goes on and on, up and down. And the x-intercept we can see from our table is 2 1/3, 0. And then our y-intercept, since the graph doesn't cross the y-axis, there is no y-intercept. So this is how you can graph the log function based off of the exponential function.